Okay, here we want to present you our work and colony optimization for open shop scheduling problem and other algorithms for other problems. First of all, I want to describe our shop scheduling problem. As we know, we have a set of n jobs and m machines and a two-dimensional table of the amount of the time each job should spend at each workstation. And we have two rules. First of all, only each Извините, что-то случилось? Ординатор просил выключить вас видео. Я чего-то не слышу.
А можете продолжать, все хорошо.
Все, извините. And the second rule that only one job can be proceed on one machine at the same time. So to solve this problem, we try to use colony optimization algorithm. This algorithm, nature algorithm, was made 30 years ago and is based on the behavior of ants. Each ant looks for a food and leaves a track of pheromones on the way back. Pheromones attract other ants. So when the ant chooses where to go, it's guided by the distance to the target and by the trail of previous pheromones. Over time, pheromones evaporate, of course, so it's working like a memory for this situation. Here you can see only three formulas: adic pheromones, calculating the probability of a path with alpha and beta like hyperparameters, which can give us flexible options to regulate our greedy of algorithm, and updating pheromones formula. The target value function hour is max span, of course, and you can see visualization for 10 jobs and 10 machines here. It's very NP hard problem. And a small line graph. The next will be more. Here you can see that in a very hard situation case, 20 jobs and 20 machines, and colony works fun, but genetic works better. The next algorithm I want to describe is particle swarm optimization. This algorithm trying to minimize functions in real dimension. So it's not combinatorial method. So it's interesting to adapt this not combinatorial method to other combinatorial problem. And here you can see small visualization for real dimension minimizing.
The next algorithm is differential evolution. There is one more algorithm from genetic algorithms family. And so here at the start of the algorithm, you have generating of individuals. Then each individual is mutated by a simple formula, which you see on the screen. Then each mutant have a crossover with some candidate from the set by the crossover rate, and then you have the selection. In our case, it is a simple sort. So this algorithm has only two parameters and very simple. The parameters is f in the formula and crossover rate from the crossover. Next. Here you can see pseudocode of the differential evolution and visualization of finding a multidimensional minimum function by this algorithm. Next. For this algorithm, we use problem as Schaefer function, which interesting for us by having a lot of local extremals, for example, in 0, 0. But we won't make our algorithm to find global extremum. Next. On interval from minus 5,000 to 5,000. And here, big optimization of differential evolution is come to us from the Japan. This is success history-based adaptation parameters. I said that differential evolution has two parameters, is f and crossover rate. So in differential evolution, they are constant, but we can adopt them by the time of working of algorithm by history of success. Next. And now the most interesting part of our presentation is algorithms comparison. We tried our algorithms on different problem, and now the first problem is traveling salesman problem, which you all know well. We test dependent on iteration and dependent on time. And so dependent on iteration on figure 1 and figure 3, and dependent on time or machine powers on figure 2 or figure 4, or figure 4, sorry. You can see that for this problem, echo algorithm is the best decision, and all algorithms find a quite well solution when the dimension is low, for example, 10. But if we make dimension is much bigger, for example, 50, algorithm like PSO, differential evolution, and shade doesn't find pretty well solution, because this algorithm is, was made for real optimization and not combinatoric. Next. The next problem is our main problem, open shop. Here you can see that echo and genetic algorithms find a well solution, but we noticed one very interesting thing, that PCO algorithms which were very bad in the previous problem, in this problem, which are also combinatoric, give us very incredible results by the iterations and by the working time. Next. And at the end, we decided to try our algorithms in their nature real environment in Schaefer function, which I will talk about. Here you can see that for a little dimension, algorithm find decision, and you don't see any adventure of shade algorithm besides the differential evolution. But if we make our dimension much more bigger, you can see that the shade working pretty well, and PSO and genetic algorithms don't find the solution. Thank you for your attention.